Hello, welcome to any combo lords joining me today. It's been a few days since I managed to have time to put something on this channel, but given that I have a few hours this afternoon and as usual, some more thoughts to share, mathematical, philosophical, or otherwise. Oh, there's a squirrel right there. Okay, I got nuts for this squirrel. Okay, hold on. Intro is actually going to be related to this. There's a squirrel over there. We'll put a nut right there. Maybe you can get that one. I'll tilt the camera if it manages to go over there. And let's see. I set a nut in the tree up there. You can see. There's a nut right there. Where are we? Right there. Now we'll also put one on a more traditional fence spot for them. And then we'll put one that's hard mode, which is going to be on the table here. If it really likes those nuts and wants to come further, it's going to have to come all the way to the desk. So, I wanted to place those nuts for the squirrels anyway, because they've been quite friendly, coming by, making some great squirrel cameos. In fact, I put a mention of that in the title. You see, I was going to call this simply Down the Abundancy Index Rabbit Hole. As a common phrase goes, to go down the rabbit hole of something, which I like that phrase, sort of tumbling down many layers and a sort of endless maze on certain topics. You can choose which portion or depth of the rabbit hole you stumble down. Well, I thought maybe a good flip of that for a dual phrase. I'm not sure exactly on how I would say the distinctions between these two phrases lie, but perhaps a good opposite of some sort to down the rabbit hole could be up the squirrel tree. You see, squirrels go up in trees. They also have many branches and tangled different paths to go to. And so today we will be going up the squirrel tree of abundancy indices. This was a topic that I put in the latest main combo class episode. That's not going to be a prerequisite in that you don't have to have seen that episode to watch the stream now. If you really want to go in a logical order, maybe you might want to consider watching that episode and then hopping back to the beginning of the stream or whatever, because that episode is my more formal presentation that is better done in terms of editing and semi-scripted and stuff like that, which was a presentation about friendly and solitary numbers. But whether or not you have seen that, in today's stream, I will explain again what abundancy indices are, which I don't think I've explained on this channel particularly. We've done it in the episode on combo class recently. And we're going to look at a few more fun facts about which families of numbers could be considered friendly, and what other traits are hiding in this beautiful thing called the abundancy index. In particular, we're going to look at the two different definitions of it, and how there's a little bridge between two ways to approach this that not everyone thinks about the bridge, and the bridge is quite interesting. To begin, let's first warm up and say thank you all for joining me on another nice day. Here it is Monday afternoon for me. I've had a busy last few days. I had a relative in town, one of the only surviving members of my dad's side of the family. My dad's dad escaped from the Holocaust as a Jewish person in Germany at the wrong time. Luckily managed to escape. But all of the family before and to the side of him, gone, dead. I don't know if I'll ever be able to get records to that. And then after that, unfortunately, my dad's parents both died, and then his brother died. And so the only people left on my dad's side of the family that I'm aware of to any extent are, because the other, distant second cousins or whatever would have required a chain that you had to go back to the Holocaust to find the link, and those records are wiped out. And so with that, the only surviving members are basically me, my dad, my brother, a few cousins, and my great uncle, my dad's uncle. And so he visited town, my dad's uncle, and that was nice. I got to, get brunch with him, hang with him and stuff. He went to a casino with my dad because he enjoys gambling and such, and hadn't done it since COVID started. and I didn't get to join that part. That night I was particularly busy. A few things I've been up to. It's semi just continuing this story to fill in what I've been doing since the last stream, and semi as an answer to the commenter who asked how I'm doing, is one fun thing I did in the past few days, apart from that, was visit a blackberry patch that has a large number of blackberries. There's a spot at what I call the marina, a stretch of coastline park-like areas where I love to visit. And as my deeper, older combo lords know, the ones who have been around a minute or caught up on the old stuff know, I had a severe injury leading up to the beginning of combo class, and I had to get 2 surgeries during grade -1. One of which was right before I started posting the episodes, and one of which was a few months into me posting the episodes. And now I can walk again. I was not able to walk properly during grade -1, so I can do more field trips. Like, we traveled to a fun park in the last episode for some of the scenes. One of the field trips I had in mind was, there's this spot at the marina that has such a large amount of blackberries you practically can't hit the end. It feels like almost an infinite quantity, in that obviously there's not an infinite amount of blackberries, but no matter how many I wanted to pick, even if I brought a little Tupperware to fill up with, there would always be more, so many more, that I wouldn't even feel guilty for the amount I had plucked. There would be so many more for all the other travelers who wanted blackberries as well. Now, this patch I visited a day or two ago, and we are at the right time of ripeness. So I scoped it out with a friend just to see, pick some blackberries. I did eat a bunch that afternoon, but also to scope out, is it the right time to film where I'll have this seemingly infinite amount of blackberries? And there is. Now, I was wondering, what should I take advantage of this blackberry patch to film? And we already did a snack break recently, so I wasn't going to do a straight up snack break where it was just a botany experiment or something. We did one of those very recently with my edible peels episode. So I figured there is something else that this blackberry patch reminds me of and connects to, which is an episode topic I've been brainstorming a while, which is a presentation of something I've mentioned before to some combo lords, which is that some people use the term infinity or infinite wrong. And there's a few episodes we're going to need to make about this, one of which is that there are multiple types of infinity. But this episode is before we talk about the multiple types of infinity. There's something also before infinity, something not infinite, but resembling infinity in certain ways that often gets confused with it. And so this is my presentation about why arbitrarily large is a term that should be used and taught more, that actually describes a lot of the things that we casually call infinite. Now, you'll see why I want to use the blackberry patch in relation to that topic. It will be a fun episode. It's going to involve card games, blackberry patches, prime numbers, and more, all in a little presentation about why arbitrarily large should join our vocabulary more. It's also somewhat a prequel to whatever episode I make in the nearish future about the different types of infinity, when we'll have to inevitably do something or another covering Cantor's diagonalization proof and why the amount of infinities of fractions versus all real numbers are different, and things like that. So that'll be probably the next episode, will be about types of infinity, but it's also going to have blackberries and magic cards and weird stuff for examples. Now, apart from that, another fun thing I did that night was, I'm a little still wiped out from this. I went to a very wild party with my friends. I love my friends. I'm definitely going to be featuring my friends in more live streams, because when I'm with my friends, it's a lot easier to bounce my humor off someone and to be funny and be engaging than when it's just me running the show for 2 hours on a live stream, you know? So with these long live things, I'm going to bring some more of my friends in. Love those folks. This was a pretty wild party I ended up finding my way into, because a friend of a friend is in a relationship with someone who must have a bit of money, And we traveled to the last house on a street, on a large street up in the hills, the final house there, and met with a bunch of somewhat hippie-like people, which I don't mean as a diss. Some people use that as a diss, but I'm unintentionally a hippie. Not that I choose to identify as that, but I like nature. I sometimes listen to the Grateful Dead. I don't mind tie-dye. I accidentally fit some hippie tropes myself, so that's not a diss, but not necessarily a praise either. It's just a character trait. There was plenty of hippie-ish people who were about to travel to Burning Man, which is this wild thing in America where a bunch of people go out into the desert and do a bunch of crazy stuff out in the desert for a while and burn this big thing and have communal experiences. And it's gotten to be maybe a rich person thing to a degree, in that it costs a bit of money to do these days. Seems like it originated maybe as a more down-to-earth, we are living out in the desert, helping each other eat. But now I think it costs a bit of money to go and to survive there. So I don't know, maybe I'll travel to that once in my life. Seems fun to do once. Have not been there myself, but due to some friends of friends going there, I ended up at a pretty fun party out in a very large house, probably the biggest house I've ever been to. So still a little wiped out from that, but I have had a fun few days. And now I am back with some filmed content that I need to edit today and tomorrow to jump back into posting more stuff on my channels again, because I do have a bunch filmed that I need to cut together. Somebody said the main thing with hippies is they don't need much to be happy. And I agree to a degree. That's a good trait, I think. That is why I think that it is a trait I can relate to in someone if they, can find peace or happiness in various places. So, I fit many of those terms myself. I don't like identifying with many adjectives. Almost any adjective someone could describe me with, I would feel contentious about due to it being an oversimplification of a person, but you need to use adjectives to describe people, and so I don't mind if someone called me a hippie, I would understand. But other nice comments as well, and somebody mentioned they don't think the universe is infinite, and that's a topic for maybe this next episode or maybe another one, the ways in which the universe could have different types of infinite-esque structures. Now, that will probably actually not be my episode about arbitrary largeness that's coming next, but my episode about fractals, because I have my own weird theory about how fractals could relate to the universe's semi-infinite, maybe not infinite status. So that'll be a cool episode, because it's like a fun hypothesis I have that I don't necessarily believe, but that is a really fun, sci-fi-ish hypothesis I have for maybe the universe is like this structure. So that'll be another one before too long. Now, about jumping into our main mathematical-ish topics for today, I wanted to go a little deeper into this topic called an abundancy index, which lives on the negative first level of the divisor function. Now, what is the negative first level? Well, I'm going to give a little synopsis of the intro to last episode, but whether or not you've seen the episode, hearing it in two different lights could maybe be helpful. Sometimes I think it could even be beneficial to people to hear me explain a topic in the edited form I make for Combo Class and in the free speaking form that I do for a live stream. Now, one thing that lives there is friendly numbers. I use these in the episode too. Now, friendly numbers are a type of number that shares an abundancy index with another number. A solitary number has an abundancy index no other number has. And the abundancy index is the negative first level. Level is my nickname. We could say the subscript is -1 or something like that. But we're calling it level because that's more fun. The negative first level of the divisor function the answer to that for a number is its abundancy index. Now, what does that mean? Well, if you add up the factors, when we say factors, some people complain that I'm just talking about positive factors, but in number theory, that's so common that often the word factors is used as shorthand for just the positive ones. We are just looking at the positive ones here. You could say that for 12, -6 is a factor, but typically the positive ones are what's analyzed, and that's what we're doing here. If we take a number like 12, and I add up all of its factors, that gives me, as if I was adding each of the divisors to the first power. What would that be? 18, 22, 28. Now, that would be like these to the first power added together. And if I wanted to count them, which is another thing we've done before, we could say that's the same function. But what I'm doing here is my function, it's called an arithmetic function because you can only plug in positive integers for it, is defined by this sigma thing. We're on -1 and we're doing it for 12. Means to take the sum of all the divisors of 12, this is a way of saying that, to the power of the subscript. So we'll say Z right there is our subscript. Now, on the first level, that gives us a sum. On the 0th level, when the subscript's 0 and we're going to 0th powers, well, each 0th power of these is 1. So 1 plus 1 plus 1 plus 1. It counts the divisors. Level 1 adds them. Level 0 counts them. And level -1 is where the friendly numbers and stuff live. Because on level -1, it would be like adding up the reciprocals of these. Like, to the negative first power of a positive integer like this is 1 divided by it. And so it would be like now adding up the reciprocals if I wanted to go on the negative first level. Now, when many people describe abundancy indices, they jump to the fact. Ah! Uh-oh. Is that more glass going on? Uh-oh. This clock is, okay. Gotta be careful with this fella from now on. Here's the 10 that I circled because it's because it's 10 is the smallest number that has an unknown status for friendly or solitary. Now, here, if we look at, we're on level -1, adding all those up. A lot of people jump to the fact that the abundancy index of a number, which is its negative first level value, can be rewritten as the level 1 sum of all of its divisors divided by the number itself. Now, that's the easier way to calculate it for sure. We're rarely going to add up all the reciprocals of the numbers. But when we say this equals this is basically defined based on it being a member of the function that on its level should be adding reciprocals. And this is sort of this other answer that we're saying it equals. Now, not everybody, when they teach it, explores the bridge. Why is this equal sign here? Why are these two different things equal? Why can I turn this to this? It looks kind of similar to have 1 divided by each one. But when I do that, that's like saying 1 plus 2 plus 3 plus 4 plus 6 plus 12 divided by 12. Why does this equal this? It's not an instantaneous thing. It's not like I multiply just by one denominator and it instantly turns into that. These are all 1s on top and all the factors on bottom. And these are all the factors on top and a 12 on the bottom. So it's like, why does that happen? Well, if I multiply each of these by something on the top and bottom to them, so it doesn't change the fraction, but it changes both the numerator and denominator equivalently, to give them a common denominator, something really cool happens. Well, if I want to turn this to 12ths, I multiply this one by 12. So I end up with 12 twelfths was the same as 1. This one we have to multiply top and bottom by 6, and I would get 1/2 is 6 twelfths. This one we would multiply by 4 and get that 4 twelfths is that. This one multiply by 3 and get 3 twelfths. And this one multiply by 2 and get 2 twelfths. And this one already is in twelfths. Now, what's cool here is that this is why I say the shift isn't instantaneous and not everyone notices the cool pattern. I didn't get the divisors in order. It's not like people might take this for granted, but you didn't get the divisors in the same order. This didn't turn it, 1/1 did not turn into the 1 up here. 1/2 did not, or 2 twelfths or whatever, or 6, let's see, what was it originally there? Was 1/2 did not turn to the 2 there. 1/3 did not turn to the 3 there. They went backwards. 1/12 was the 1. 1/6 became the 2. 1/4 became the 3. 1/3 became the 4. 1/2 became the 6. And 1/1 became the 12. They went backwards. Because factors come in pairs. It's not something we should take for granted that we got the divisor list again when we turned it into a simplified form. It only works because a number's factors come in beautiful pairs. And here is the example I used in the episode, or one of the examples to show this one again clearer, was 36. Well, if I have 36, here I got the way that it tells me to do it, the negative first power of them added up, and turn it into reciprocals. Then if I common denominator them, although I do end up with the divisor list divided by the number itself, it's backwards. The backwards is okay here because with addition, order doesn't matter. Now, because, A plus B is B plus A in the real numbers. Now here, we can see they went backwards. 36, 18, 12, 9. 36, 18, 12, 9. And that's because basically these multiply. 1 times 36, 36 times 1. 2 times 18 is also 36. 3 times 12 is also 36. 4 times 9, 6 times itself, they're all 36. So when you do this conversion, it works like kind of magically that you try and common denominator the reciprocals of all the divisors, and it gives you the divisor list in reverse, and you can write it in reverse or not, adds to the same thing, divided by the number itself. Now, that would even work if I say in a generalized form, like, what if I have a number that has a semi-prime number? That's the name for a number that is like PQ together. It's P times Q makes up the number. It would have factors 1, P, Q, and PQ. Well, now if I add the negative first level of this to find its abundancy index, that will be 1/1 plus 1 over P plus 1 over Q plus 1 over PQ. Now if I try and common denominator these, this goes PQ over PQ. This goes Q over PQ. This goes P over PQ. And that one already is common denominated. And I got them in reverse. 1 PQ PQ. So you could even do this in a generalized form. If you take any number and its factors, try and do this, you'll notice, well, the symmetry of divisors, where they always come in pairs. Even if there's an odd number of them, like 36, the middle one pairs up with itself in a way that works here. We're able to do this abundancy index shift and turn it into the first level over itself. Now, the abundancy index also just gives us alternate definitions for a lot of number nicknames. Like, if a number is a perfect number, that means that all of its factors apart from itself add up to itself. You could also say that all of its factors, including itself, add up to twice itself. You can also say that the abundancy index equals 2. Perfect numbers have an abundancy index of 2, and that makes them friendly with each other. Friendly numbers are ones that they're friends are the ones that have the same abundancy index as each other. So, like, for example, you might have a club of friends over here that's like all the perfect numbers. You might have a club of friends over here that's like, this one might have 30 and 140 happen to be friends. They both have an abundancy index of, I put it in the episode, I'm pretty sure it is 2.4. It's in the episode for what it definitely is. And there's another one that's 24 and a number that is way up in the millions. Here we can see what Wolfram Alpha, a sort of cool Wikipedia-like resource, has to say about some of these friendly numbers. They actually have a separate article for friendly pair that describes it a little clearer. And here is an example. 4,320 and 4,680 both have an abundancy index of 3/2. That also gives them the nickname hemi-perfect numbers. Hemi with an H. Those are numbers with a half integer abundancy index. Now, this is also a hemi-perfect pair, but a different one. 5/2 instead of 7/2, that's 2.5. And this one is 24 and the large number I was talking about. And that shows that if you wonder if a number is solitary, you're going to need to prove it's solitary, because if you just check a lot of numbers, its smallest friend might still be out there, but just beyond the range you've checked. If you checked 90 million numbers, you wouldn't find any friends with 24. But if you get up to this number, it's friends with it. So you can also hear, these are some things I didn't note in the episode that are cool, are that, yeah, you can have friendly triples and higher tuples, meaning higher amounts in the string. And I think that was sort of implied by the episode, because the perfect numbers form a rather large club of their own. We know that there's like 51 at least perfect numbers that are in their club. So you can get clubs with non-perfect numbers as well. And you also here can note that, I don't know if they mentioned it here, but they don't know if it's possible yet. I don't think they say this here, but it's true that they don't know if it's possible if a club of numbers of friends in this way can be infinitely large or not. They don't know, for example, if you could have some certain abundancy index that an infinite amount of numbers have. So there's still a lot of mysteries here, one of which is that the number 10, even, we don't know if it's friendly or solitary, whereas other numbers we have proven are solitary. Now, some other cool notes on this. Wikipedia has a pretty good table. This shows us some status for small n. However, they color code it a little weird in that the blank ones are actually the same status as the red ones. It's just that they follow a much easier proof. So basically, if the number and its divisor sum, and this is implied to mean the first level if we don't see a 1. If we see no subscript, it implies 1. The first level divisor sum, if that is co-prime with the number, and that means they have no factors larger than 1 in common, then it's guaranteed that the number will be solitary. Another way of phrasing that is that this fraction is already in simplest form. If these aren't co-prime, this fraction can be reduced further, and if they are co-prime, the fraction is in simplest form already. So any of these, the fraction was already in simplest form when you just looked at the numbers, whereas this, for example, 78/45 actually did simplify to 26/18 or 26/15. Now, the reds, though, are just ones that it was harder for them to prove solitary. They had to use other techniques because they weren't already co-prime. But status-wise, the blank ones are red, too. They were just basically proven in this much easier to deduce way. Now, blue means friendly. There's a perfect number. There's 12 we mentioned. 12 smallest friend was pretty big. And there is... Oh, no, 24 was the one with the smallest friend that was really big. This one is friendly, though, 12. And a variety of other interesting ones that happen to be friendly or solitary. Yellow means unknown. So 10, 14, 15, 20, 26, 22. Unknown. So remember, I'm always a little begrudging to give 10 too much credit because 10's overrated in our base 10 society, and we definitely should switch bases someday to base 6 or something. So I'm always hesitant to give 10 too much credit at risk of making people think, oh, the base is good for us to have. So if I ever give 10 some credit, remember, does not relate to the base. The base relates to, it's 2 times 5. Less practical than 2 times 3. Now, it is true that there are some cool things about 10. It is triangular, it is tetrahedral, and it is the smallest number currently unknown for friendly or solitary. So, that's a fun one. Somebody said, is 7 friendly? They heard they like to eat other numbers. And it's not, it's solitary. 8/7 is has only one number with this abundancy index. Now, thank you all for joining me and leaving some more fun comments. Let's look at one last thing here, which notes some things about, this is one more article they had here. They don't have much info here, but going off this with, facts I know, the multi-perfect numbers are cool. We already showed those a bit in an earlier episode about aliquot sums, the one on my combo class channel about 13 strange numbers with weird names. And the other friendly numbers and stuff have different traits as well. We also want to remember that another notable trait are if a number is on which side of being perfect. There's only one number with an abundancy index of 1, the number 1. Every other number has an abundancy index larger than 1 because its divisors will add up to more than itself. Now, beyond 1, the question often becomes, with this categorization, which numbers are more or less than 2? The ones that are exactly 2 are called perfect numbers. But if your abundancy index is less than 2, those are the same numbers whose proper divisors add up to less than themselves, or who all their divisors add up to less than twice themselves. And those are numbers called deficient numbers. Oh, those numbers got a poor name. Sorry, deficient numbers. On the other hand, we get abundant numbers as the name for ones with the abundancy index more than 2. Similarly lining up with numbers whose proper divisors add up to more than themselves or all add up to more than twice. Now, those have some interesting traits, abundant versus deficient versus perfect, and maybe it's even interesting to look at which sides of other numbers we lie on. Perhaps we should have nicknames for which side of 3 is a number. Much more numbers would be on one side or another, but could be interesting to see what proportions of numbers on the number line on different stretches are more or less than something like 3, or 4, or beyond. Now, the abundancy index also gives a bunch of other nicknames. Sometimes there are confusing nicknames in this category of number theory because there's something called amicable numbers and sociable numbers, and those are different than the types of numbers called friendly numbers. Sociable numbers are numbers that have their proper divisors add up to another number that comes back to them in some sort of loop. Amicable numbers are when the loop is just 2 numbers in length, which is if you go down taking the proper divisor sum, then divisor sum of that, then of that, of that, going down an aliquot chain. The loops there are called sociable numbers, with the 2 length loops called amicable, which sound confusing at first with friendly. So remember, friendly numbers are a little different, the ones that have an equal abundancy index to another number. A little different than amicable and sociable. There's other confusing ones as well, like, I don't know, there's a lot of funny names. Sometimes I mix them up with impolite numbers and polite numbers. There's a lot of good nicknames there. Now, I think those number nicknames are good and can be fun tools. Make sure at some point you also check out this older episode I made, which was the one about the aliquot sums, is this one. This is a good extra view at this topic from the approach of aliquot sums, which, if we want to define in terms of our divisor function here, the proper divisors isn't on its own a level there, but we could say level 1 of the number minus the number itself is the aliquot sum. So kind of funny that in that episode, all of our cool nicknames and stuff were based on level 1 of n minus n, because that leaves you with just the proper divisors, whereas this episode was level 1 divided by n. Similar, but different. So yeah, that's a fun connection, aliquot sum, level 1 minus itself. Abundancy index, level 1 divided by itself. So, these are some more visualizations on here. The friendly number index of things up to there. So these are, that's a wrong term. I would not call this the friendly number index. I mean, I don't mind that, but typically this is called the abundancy index. And friendly numbers are ones that share it with something else. So to share it, you'd have to have something else on your same horizontal line as you. So this is interesting. We can see like some of these are it looks like a few of these are right on 0, but they're not. They're just like really low numbers. We would need a closer visual to actually see those low ones. Kind of cool scattering though. These are just the sum of the factors if you don't divide by it. This is the level 1 answer for a number. So here we have n going pretty big scale pretty quick. And here we have the divisor sum. That's pretty cool. All right. Now, here they note that thing I said where it's unknown whether there are infinitely large clubs of mutually friendly numbers. Now, if they find the next perfect number, the 52nd one, like I've mentioned, it will likely be linked to a prime that is the largest prime ever discovered, or if not, a prime that is one of the largest ever discovered, because perfect numbers are each linked to a Mersenne prime, which includes some of the biggest ever. So Mersenne primes, if we look at, like, where's history of large primes, just to see the list of primes they've done. I don't know, it's somewhere on here. It's like 8 or 9 of the top 10 biggest primes discovered are this type called Mersenne primes, which hyper 11's in binary. So people are wondering about 7, 8, 9. That is a classic number gag, that 7, 8, 9. I'm not sure if that will be provable based on abundancy index. Our proof that 7, 8, 9 might have to come up in some other context. Now, this is another interesting trait here that says the natural density of the friendly numbers, if it exists, meaning if there is a ratio of how many have occurred on the number line per natural numbers that approaches a steady rate. Like, if you look at all the prime numbers and what proportion have happened, it approaches 0%, even though obviously there are primes, but it approaches 0% of the amount of numbers have been that. If you look at even numbers, it's going to approach half. Like, 1, it's 0 are even, now half are, now 2/3 are, now half are again. It gets closer and closer to just approaching half from any point. So if there is a natural density approached by how many friendly numbers are on the line, that it's positive, not 0. Positive here means it wouldn't be negative, but this means that it's non-zero, so that it doesn't just go toward approaching 0 like the primes do, if there is a natural density, which is interesting. Some people say the density could even be 1, which someone thought they disproved, but they didn't actually successfully disprove it, which is pretty wild. That means you get more and more friendly numbers up the number line, if this turns out to be true, approaching 100% of numbers being friendly, which is certainly not true on the small scale. The first 6 numbers, only 1/6 are friendly, you know? So those are some more interesting facts about it. We can also look at some sequences on the OEIS that relate to it. For example, here are friendly numbers. 6, 12, 24, 28, 30, 40. Oh, 42 is friendly. Classic 42. People like that one because of Hitchhiker's Guide to the Galaxy. Great book series. And we get so many classics. Look, long 100. That one's tri-perfect. It's a 3 perfect number. We get 60. We get 30. Oh, we get a lot of classics here. 12, 6. Ooh, boy. And 24. All these divisibility champions are on this list. 360s on the list as well. So divisibility champions turn out to have not only so much divisors, but at least on this small scale, their divisors often add up to a ratio compared to themselves that other numbers also have. That's interesting. Here they also note one more fact, which says that up to 372, they have checked that all the numbers that are unknown status, if we like 10 and 14, that we don't know if they're friendly or solitary, are not friendly with anything up through 10 to the 30th power. So they know that 10 and those other ones would be solitary if there were only 10 to the 30th power numbers. So we don't know because, for example, how large 24's smallest friend was, whether or not this means it's solitary or not. But we know that if 10 has a friend, it is a big friend, larger than 10 to the 30th power. Here is the large number that 24 was friends with, by the way, right there. So, lots of fun facts and stats about friendly numbers. Now, that is most of what I wanted to talk about for the main intro and meat of some stuff related to the last episode. So I think we were going to switch topics in a moment to some other scattered mathematical topics involving some graphs, maybe some nature around here and things like that. So if anybody leaves early, because I'm going to go grab some water in a moment, it's also a likely time. A good reason to stay is that the squirrels are more likely to come while I'm gone. And then you can tell me if a squirrel came. But in any case, if anyone leaves early, make sure you've seen those combo class episodes I mentioned, the latest of which is linked in the description. Stay tuned for more stuff dropping on this channel this week. And additionally, the next episode on the main combo class channel will be out not too long. I've been getting them out a little more than a week apart from each other. Probably be similar. Probably be about a week or a little more than a week after the last one I dropped. Which means could be out in like 4 days or something if we're lucky. Now, let me run inside, grab some water real quick. I will be back. Leave any thoughts or requests in the chat. And we are going to be looking at various fun graphs and things when I come back. Let me make the background large in case any squirrels do anything silly. Alright, folks. Thank you for sticking around to any combo lords who are watching this live and hanging with any potential squirrels. Unfortunately, we don't have any comments that say, there was a squirrel in the background, and I do still see all the nuts, so probably wasn't a squirrel. However, you know, maybe one will come later in the stream. They've been coming quite frequently. One of the cats here, my cats like chasing things. Now, Sage is actually kind of a savage hunter. I can't help it. He's gotten a few birds. I can't help it. He also has gotten rats that were in our house, like chewing out the dishwasher and stuff. He would be an old school good mouser cat. Like, he one time stalked out, staring at the stove for days, perched silently a few feet from it, waiting for his chance, knowing there was a rat hiding under that stove, sneaking around and chewing our wires and stuff. I'm not anti-rat. Rats can be great pets, but unfortunately, they are pests on a house. It cost my family a lot of money to replace the dishwasher wires that the rats chewed out. And so he got that rat. So Sage did a good job there. Dandelion is fluffy and is way too clumsy and silly to catch anything. Dandelion's a creature of pure love. He's the silliest cat of all time. I don't even think he's a cat. He's an alien of some sort. So he cannot catch an animal. One time he brought me a stick, really proud, like, look what I got. And then Sassafras is the newer cat. They were all sleeping so close to each other. I'll send a photo on like the next stream or something and show it. They all sleep so close to each other. It's so cute. And the new one was a stray, and they've like let him in the family. And Sage gets a little stressed out because he like looks really similar to Sassafras, and you might feel like, oh, am I getting replaced or something? Because Sassafras is a little pushy and like, hi, I want love. I want love. I want the food. In a nice way, like he doesn't want to hurt any other cat or whatever, but he's a little pushy. And so it stresses Sage out a little, which we're working on. But Dandelion has totally taken Sassafras under his metaphorical wing by just being like, all right, Sassafras, you can follow me around wherever. I'm going to get pets. You can follow me and get the pets with me. So usually Sass and Dandelion will come as a little alliance, both trying to get pets. So sometimes in the morning there's 3 cats and only 2 hands, and I don't know what to do. Oh, not enough hands for the cats. So those are very great. We'll make sure to get more cat meows in the near future, and sometimes they even visit us back here. Now, I wanted to show some graphs in a minute, possibly. One thing I also wanted to note that's sort of funny. Let me see if I'm going to actually show any of the video of this right now. I'll pull it open while I explain what it is and see if I'm actually going to show any of the video. I have a lot of old home movies. And some of them are even scattered on YouTube channels, and some are when I was really young. So they weren't on, I don't even know if YouTube was around when some of the younger ones were filmed. And there's a variety. Like, I had a friend in middle school who I filmed like 30 comedy episodes with. Not like episodes, but like short, singular comedy films. Like 30 of them. They were like 5 to 10 minutes each. And someday I'll show those. But also, even before that, there was some really old stuff I filmed on tape recorders. These miniature, I believe it might have been the thing called a mini DV, that was these little tapes. A mini DV is like, goes into these certain handheld cameras, and you film it on this little tape, and if you wanted to watch it in the TV, you have to like put it in a larger converter thing that turns it into an old VHS. Now, I don't even know if some of my viewers, there's probably some of my viewers who don't know what a VHS is, but this is actually how I watched a lot of films as a child. I mean, I'm only 30, but my family's a little old-fashioned, and these were around not that long ago. And so before you would rent CDs at the store, you would get these to watch movies on. And we had a little converter as well that you could put the mini DV in, and then you could watch it on something. Now, a lot of these home movies, some of them I was so young that it was like my mom helping me film some random idea I had. and I think I've located the first film I ever made. Now, I'm sure my mom did most of the filming of this and figuring out how to actually make that work, but I had this idea in my head when I was really little, and for some reason, the tale I wanted to tell in this movie I wanted to make is called Invisible Rats and Elves. And I've remembered for many years, at one time, way when I was young, I tried to make a little movie for fun called Invisible Rats and Elves. Well, I have located the Invisible Rats and Elves footage and converted it. It's all the old mini DVs, digital now, baby. I got digital files of all of those crazy old home movies. Now, I'm gonna have to filter through them before I just like show them randomly on screen. I don't know if it's gonna have like addresses or like some random thing I don't want to show the camera. I don't know. But some of this is footage from Invisible Rats and Elves. And I'll show a tiny bit of it. Now, I need to cut together the footage because this is like on a tape that like goes into other random stuff in the midst of it. So I'm not sure exactly, but this is just in the middle of the tape somewhere. We're just going to watch like 1 minute of Invisible Rats and Elves, which is so guys, I don't remember whether the invisibility distributes between rats and elves. I don't remember if I meant invisible rats and elves, or if I meant invisible rats and elves. So we're gonna have to deduce what society needs more parentheses allowed. We need to know when adjectives distribute or not. Now, all right, we're watching a sneak preview of Invisible Rats and Elves before I actually cut some of it down. This will probably be really bad. Let me try and make the audio come through the computer. I hope this works. I'm going to try and have the computer do the audio instead of...
Invisible Rats and Elves.
Who's deal?
What are we going to do this afternoon? Play cards?
Let's sit in the sun and play cards.
Okay.
Perfect.
Who's going to deal?
I'll deal. Do you want to cut it?
Sure.
Okay. Thanks. Let's see, how many cards do I deal out?
Hey man, you're cheating.
Okay, I'm done.
I want that card. What game are we playing?
That's this game I learned in Holland.
What
I'll tell you about it as we
deck
go.
is this?
What have you got? Oh
Okay.
Okay, that's me in the rat costume, by the way.
What do we do?
Oh my god! Look at that rat!
It's the biggest rat I've ever seen.
Quick, call the police.
Oh, what are we
You
gonna
have
do?
a cell phone?
No, keep playing cards. I'll only leave when you get a full house. And one of you gets a full house.
Whatever you say, Ratty.
Oh my god. I'm a little scared.
I've got pretty good
Frankly.
cards. I'll take you on.
I've got a king and some nines and an ace.
Don't tell him what you got. So what cards do you have, rat?
What do you mean?
Here, take these.
Boy, it looks like Rat has a pretty lousy hand.
Yeah, I don't think you're gonna make it, Mr. Rat. That is your true name.
What card do I have?
Whoa.
What's that?
That's the weirdest
Wow,
card I've ever seen.
trippy.
Yeah.
Here's the elf card. When am I gonna ever get him?
The elf card.
I don't know. Oh my god.
Oh,
Ah!
I need to pause there to note that, so yes, I was playing the rat, and then at this point it shifts and somebody else is playing the rat, and I start playing the elf. So, to whoever came late, this was probably the first movie I ever made, but then this tape goes to like random other footage, so I need to actually cut down which parts of this whole cassette were invisible rats and elves, and which parts were just weird other bits of life from my childhood. So, like, there's other surreal things. Now, going through this footage with the old tapes reminds me of, like, I don't know if any of you ever watched or were into found footage horror or surrealism, but it's a genre I've enjoyed. Like, one of the original things that began that was the Blair Witch Project, this film that marketed itself as this was a real tape that was discovered after these people got lost in the woods. And it was so old that the marketing actually worked pretty well and convinced a lot of people that it was a real tape, because it was one of the first films that was filmed in this super low budget way that all of the footage you see is taking place in universe. In universe, whatever you see was filmed on some device. And I enjoy that sort of aspect, almost reminiscent of how some books might be first person in the way that they are a written journal or a written catalog of some sort that exists in universe. And so I'm interested in that sort of thing, and there has been many good YouTube channels that have followed that sort of vibe. The one that brought it to YouTube on the forefront first was a series called Marble Hornets, and someday I think I'm actually going to do an analysis of why I think the character of the Slender Man who was used in that is actually, although it's become cheesy from society, actually is a really cool mythological entity in concept, and society has turned it cheesy. But using that mythological entity in an interesting way, there were a lot of other series inspired by this Marble Hornets show that were YouTube channels that make it seem like this is actually happening in universe. Like, all the footage you're seeing was filmed by someone, but then crazy enough stuff happens that the viewers are like, wait a minute, were they secretly planning this? And not like a type of scam where you're pretending your vlogs are real and hiring strangers, but more of like an art project where you're fully playing a character and you devolve it into utter surrealism. Now, other interesting ones like that are this really weird series called Alan Tutorial. There was other good things similar to Marble Hornets, like Everyman Hybrid and Dark Harvest and Tribe 12, and other channels that were interesting. And someday I'm going to make an episode analyzing those. But right now it reminds me of that weird mood where I'm going back through this old footage and it'll like suddenly cut to some weird dark scene in the woods where I'm as a child looking at something I don't remember anymore, except for this footage existing of weird stuff that happened in my childhood just flashing between different scenes. And I half expect there to be some strange mythological entity in the corner, or some weird cryptic symbol that I now have to revisit to find. So we'll see what weird, creepy lore I find in that. As we call all of the stuff before Combo Class occurred Grade 0, we can we'll find some rare Grade 0 lore. Speaking of the grades, we are approximately 1/3 of the way through grade -2, so thank you to everyone who's been joining our grade structure. And the grades are somewhat tied to years or like seasons of a TV show or something, but there are other standards to which I know the grade is complete, and grade -2 is continuing to evolve, so I have fun plans coming up. Some of the episodes that will come out, not immediately, I'm still going to be doing similar things in the near future, but there could be a month or two in not too distant of a future where I take more like 2 weeks between a few full episodes, but they're a little longer. There's some topics that I've been postponing because I can't really do them justice in 10 minutes. So some topics I may make a half-hour episode that takes me more like 2 weeks. But a lot of fun stuff coming up in any case. Like I said, our next episode, I will be traveling sometime in the next day or two to a large blackberry patch to film a scene. Now, I can imagine people are joking about the directorial amazing status of my Invisible Rats and Elves film. On a real level, I will show you more of my home movies at some point in the future. They're quite funny. In more of a... They're funny in like a 30% you're laughing with it, 70% you're laughing at it. But, you know, still fun. And the... other ones, there's so much rare. You guys don't even know all of the channels I've made. I'm going to start dropping music on this channel at some point before long too. So at some point I will reveal some of my older music. And all I'm going to say is, well, here's one more piece of the lore. I don't know if I said this exact detail before, but I was reminded of this after hanging out with some friends who are somewhat doing their own sequel to this year. Some of my friends are trying to record 23 random album or mixtape type projects over the course of 2023. Now, this is actually a throwback intentionally to something that I did 10 years ago. 10 years ago in 2013, I released 13, I called them mixtapes because, yeah, those were more like mixtapes. They were over, a lot of them were over other people's beats, and I was just doing rapping or singing on them. So I released 13 mixtapes in 2013. It's not under Domotro. It's not going to be easy to find, so just wait, and I'll let you guys see all that stuff before too long. Now, maybe I'll have to do a flashback to that on New Year's of this year, because on New Year's almost 10 years ago in 2013, we only had like a day or two before New Year's. I was going to throw a huge New Year's party here, and we only had 11 of the 13 mixtapes finished, but we had wanted to do 13, and me and some of my friends spent like 3 days just recording albums and then preparing for this party, and we had to record the last 13th mixtape and release it during my New Year's party to get it out by like midnight. And so the 13th one ended up just having all these people who were at my party just like doing random freestyles because we were like one mixtape short. And so I just got like some crazy, ridiculous squad tracks with like all of these random people who I forget who got on those. But I've also released albums that I've made all the beats for and stuff. And that stuff, yes, I will release at some point in the future. As well as we'll release the director's cut of Invisible Rats and Elves. So leave a comment on if you think we're going to find out that the elves are supposed to have invisible in their name too, or if it doesn't distribute. Now, let's see what's next. Another thing that I always like to do in our streams is pull open fun graphs that are new. And there are more variations on the last ones that we were trying that I think would be fun to throw in. So while we chat for a moment, which this won't necessarily be our next main final topic or anything, but while we chat for a moment, I figured let's look at a few fun graphs. Now, the type of graphs we've been having a lot of fun with recently are called polar coordinates, where we're looking at the radius being something like an angle. This is r equals theta, and I can say how big I want it to go. We'll have it go to 100. If I want it to have a certain type of symmetry, I can go like negative 100 to 100. Now it's sort of doubling up. We'll just go 0 for now. And we noticed that when we put trig functions on these things, it makes really cool shapes. This one's quite optical illusion-esque to me. It looks like a cone. Tell me if that looks like a cone to you as well. Now, what about if we say other ones like tangent get a little wild? There's tangent. And yeah, we haven't even seen this one much yet, but that's cool. And one of the really fun ones was stuff like secant, where we need like some variables were what we were doing more here, I believe. When we say something like r equals some coefficient times the secant of a and theta. I forget if we mostly put a theta before that or an a. These are both wacky. Whoa. We can also try turning them into inequalities, although sometimes that makes stuff too dark, but that looks pretty cool. And what happens when we turn that to a? Not much. Less. Okay, that one was more boring. When we turned it to theta, that was much more cool. So these are cool different spirals we can get. And we also tried things like cosecant. Now I'm going to turn off the inequality and go back to straight lines for a moment, because we can see some extra patterns here. Wow, look at that like spiral shape forming. Ooh, whoa, look at this. When you zoom out, it's hard to see any spiral shape. Oh yeah, look at that spiral. This is such a cool pattern. Whoa. Sometimes it's hard to see the spiral, but look at that spiral that's there. What happens when we inequality? Okay, no, too crazy. Now, I was figuring some other things we can try throwing in that we haven't tried on these variations of polar coordinates yet. Include square roots. Here's if I have a square root in the secant. Now it's like this spinny thing that's actually going a little more like stable almost. The square root almost made it like flow in a more consistent way, but it has these extra threads that are flying out. Now, what would have happened if we had, for example, had two variables just so we can have more variance? Here's A versus B in this case. Oh wait, I didn't have an A anywhere. We'll have an A there too. Now A is just going to grow and shrink it there, I guess. But it makes it look cool when we put these on scales. Because, you know, we can put these on animations as well. And when we put these on an animation, we're going to try and make the speed as slow as possible. So these are pretty wild. Now, what happens if I inequality it? Is it just going to be too much? Yeah, it's just too much. What about that direction? Yeah, just too much. Okay. What if I change which thing the square root is under? What if we put the square root further? Or even closer first. First, we'll just try the square root right there. This one's pretty wild. Whoa. So when you're close, we just see these spiraling things. And when we go out, we see what chaos they are part of. All right. Now, and it's making more spirals. So, what if we put the square root a little further, though? This one's a little more chaotic. Ooh, look at this thing growing. Ooh, it grew it. Whoa, it ungrew it. These ones are moving and growing and shifting it a little different. Now, what if we put it... We're going to remove the A for a second and just have one thing. Under there. Uh-oh. Too much, too much, too much. Uh-oh, I hope I'm not, like, overloading the computer. It's starting to go slow. So that's not just on your end. I'm going to close all these other tabs. Okay. Okay, yeah, this is starting to go kind of slow. We're going to just restart this. We'll see if that makes it speed up again. R equals... Now we're done with square roots for a minute. We're going to say mod. Mod is another thing we can do. We're going to say in mod A... theta. This is a simple start for our mods. This is R equals theta mod A. What if we like symmetricalize it? Whoa, this is strange. All right, now we're going to get back to having some of those trig functions like secant in the mix. Oh, now it's only on one side, but it's growing a cool flower. What if we put that somewhere else? Like, what if we put it all the way around here? Whoa. That's doing a lot. So, mods have the chance to get quickly out of hand, so we're only going to do a few of the mods before we have to filter them out, but they're doing kind of their own pattern. That's a little bit neat. And let's make it now just 0 to there again. This is interesting. Whoa. It forms a little dance of sorts. Now, what about if I Let's try a few more trig functions just here first. There's the sine. Watch out whenever we do tangent. It gets extra crazy usually. And let's try like cosecant. Cotangent. Alright. And there's just that one. So those can do quite neat things. Now, alright, we're just going to try mod and square root once. Could be a little too crazy, but let's see if mod and square root works well. Forms this thing. And if we try and get extra crazy by putting one of these on, we get a extra crazy pattern forming. So, whoa, that's doing a lot. How about a chiller one? This one's more contained, but it's still going really fast. Oh no, my speed sped up somehow. There we go. Now we're back on a better speed. Now this one's self-enclosed, but you want me to make it bigger? Oh, wait, no, it didn't make it bigger. That's funny. It just made it, whoa! So it grows to this size, and then it hits its limit. It won't go past 1. It doesn't want to go past a radius of 1. Look at that. It just doesn't want to go past a radius of 1 on any side. So, that's pretty neat. Now, let's simplify this a bit. And we're going to try more variations on, I forget exactly what the combo we did last time was. We're going to just say theta, secant a theta, and find variations on this simple beauty. This is one of those ones that does a spinny thing there and strange, crazy spot. Whoa, look at those spirals. Whoa, whoa. Okay, so this one is absolutely wild when you go to certain scales. It like hits these optical illusion moments. Okay, so to find variations on this beautiful one, we're going to now try adding exponents. Instead of saying a times this, we're going to put this to the power of a. What is that going to do? Well, it's only going to work on certain things. So, like there's negative... Oh, no. It worked on some of these levels. There we go. Oh, it might just be too much for the slider to handle. It's giving it trouble again. But it's pretty neat. Some of them are simple like this, and then some of them get pretty wild. Now, what if we try and say divided by a? Whoa! Whoa! That was too much. Okay, I'm going to zoom out, but I'm going to not let the slider go. I'm going to control it. Whoa! Whoa! That one's simple and weird. Whoa! Look at that. That's cool. Somebody asked, what is this? This is just me making up equations in an experimental fashion on the app or the website called Desmos. Great website, not sponsored or anything, but a good simple graphing calculator out of many options like that. And so it's a good simple graphing calculator that we are programming what's called polar coordinates right now, and I'm just making up random variations to find some beautiful looking ones. Now, be on the lookout for what it looks like, because as you know, it can be fun to like say, hey, that one looks like a bug or whatever. This one's funny. It's just spinning this thing. What if we said minus? Is it going to do the same thing? Yeah, same thing. So now let's say we had a, and did we try it? I need to just try this variation of it to make sure. I think we might have tried. Whoa, this one's more circular. Maybe we didn't try this. This one has like one thick ring. That's weird. Why is that ring so thick? So, interesting status as usual. Now, what if we say we're just going to go to theta squared. And we're going to need the a in there somewhere too. Oh man, this is really glitching. Okay, I'm going to restart this again. Maybe that'll help. I don't know. Restart, please. Okay, I hope the stream's not that glitchy because I'm having trouble even just making this internet page work. Okay, r equals a... Oh, no, we don't need the a there yet. Theta times We'll go with secant of A times theta squared. So what's squared going to do? And actually, no. Let's say to the B. We're going to make another slider. So here's the thing, though. I'm going to make B whole numbers for now. Or no, we don't need to. We can let B go crazy. So here is when they're both 1. Here is if A is 1, but I edit B. Whoa, it's glitching. Okay, some of these seem to be a lot for the program to handle. Maybe we'll someday have to try other graphing softwares as well. I did try the one called GeoGebra, and it didn't seem better for this type of task. There were other tasks it would have been better at, but not necessarily this one. Somebody said, can we try the Fibonacci sequence? And I'm not really sure what you mean by that, because do you mean graphing the equation for the nth Fibonacci number? We could try doing that sometime, but for now, there's not really a formula that is the Fibonacci sequence. There is a generalized formula that will pass through those numbers, but might need to be more specific with which one you would want me to try sometime. Here's when we change A's to things. So like there we get 3 spikes, 3 even. Oh, because A's on 3. If A's goes to 5, I bet you it'll have 5 spikes. Yep, 5 spikes. How about A on 4? Didn't have 4 spikes. That's interesting. I wasn't sure if 4 would. I'm really lucky I guessed 5 like that, because I was like 3 did it. I'm betting that at least all the primes do it, and maybe all the numbers. And it looks like all the numbers don't. Like when A is 4, it doesn't have 4 spikes exactly. When A is 5, it does. Is that because those were primes? When A is 2, it didn't. So that's a prime. Does it have to be an odd prime? When A is 7, it makes 7 spikes. So that's quite interesting. It almost seems like only when this A value... Well, no, 9 did it. Is it any odd number? Yeah, perhaps any odd number will create the amount of spikes. In any case, I'm glad that except 1. Huh. Any odd number bigger than 1, maybe? I don't know. Strange. Maybe this is considered 1 spike, because it's just on one side of the screen. Now, what if we let these... This is probably going to destroy the computer. Oh, no, whoa. Okay, that was too crazy. No, I hate when it zooms in on the page and not on the graph. This is going really crazy and giving it trouble with that exponent up there. We're going to have to try something else, and what we're going to try is getting rid of the exponent and seeing if they like division more than exponents in how they can handle me trying weird stuff. So, sorry to the Desmos owners for probably eating up like half your hosting bill for the month. This apparently takes a lot of energy, but I mean, no, I haven't heard that. It's just that maybe my computer just has trouble with it. But in any case, I love making these graphs. Now, okay, so this is doing some wild stuff when we have A divided by B. Here we have like 3 threads, but they're like these like... I used to make patterns like this that I would call a line design. I don't know what the technical name for it might be, but when I was bored, one thing I used to doodle was you can make a pattern by... You make a sort of graph-like structure. And right now, I'm just going to be using one axis, but I could make it like a whole star-like 4-way thing. But if I just have one, I like make a certain amount of dots on it. We'll say, okay, this goes up to 5. And then I connect highest to least high with a straight line. Second highest to second least high. Third highest to third least, and you know what I mean? It makes a cool web-like pattern. Especially if you do it with even more dots. It makes quite a neat-looking web. That was something I used to doodle when I was bored in class and stuff. And this is reminiscent of that, where when I'm right here, it's sort of like a line design version of those 3 spikes that we saw earlier. Although neither of these are set to 3, interestingly. Look at these interesting spirals. Now, whoa, that's cool. Look at this spiral building. Line, 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 line. Crazy, 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 crazy. Woo. That's whoa, it looks crazy at like any scale. Whoa. All right, you ready to fall into the portal? See, this is sort of that line designy trait right there. They're straight. These actually might not be straight lines, but they look straightish. I'm not sure if they are or not. So those are fun. What other ones can we hit on this scale? Well, if we let's set B to particular values and put just A on a slider. This is when B is 1.7, and that is going way too fast. I need to find a way to make the default be really slow. Now, if B is set to 1, here are the A's if we let A rotate. On this scale, it looks like that. Let's go out a tiny bit. Okay, a little too far out. Whoa. Now, what if we set B, because B being 1 is something we've probably seen before, because we're just dividing by 1 there. So what if B is 2? Now we've cut it in half. Whoa. Whoa. Okay, how about B at 3? Whoa. That's wild. Whoa, that would like spun like a yo-yo in this weird outward way for a second. These always keep doing new cool things. Now, when we did normal graphs and certain types of polar coordinates, it would be like, this looks like a bug, this looks like a flower, this looks like an eye. These ones are more like optical illusions or like whole little universes. Now, what about one more try? We'll try B at -1. See what that does. Similar to 1, I believe. All right, so that was pretty wild. And what happens if we put the B all the way out here? Not too different. In fact, maybe even a little less okay, maybe not less interesting, but pretty similar. Now, we've tried exponentiation in those others. We could try addition or subtraction. I'm not sure if this is going to do too much, but what happens when I have plus B being added? That's pretty wild. Now, I hate when it zooms in on the page and not the graph. Okay. So, those are all pretty neat. And let's try simplifying something where we're going to go back to over B, but you know what we're going to do? We're not going to put a theta in front. Then we can add more changes. But, whoa, this might be too much. Whoa, is that my origin? Is that the origin for some reason? Remember how last time it didn't want to touch the outside of the 1 radius circle? This one doesn't want to touch the inside of the 3 radius circle. It's like the reverse of that one before, where that one would go really close to being outside of 1 radius circle, but not quite. This one will not go inside it. That's pretty wild. Yeah, look, it just doesn't want to go in that circle. It will do any other cool thing but go inside that circle. Whoa, look at this one. This one looks like a tablecloth or something, but it's cool. Whoa. That's pretty wild. What happens when we change the B? Oh, the B can make it like way less dense. We were at like one of the denser types of B when B is higher. Whoa, this one's like barely even touching toward the circle. It's still not within the circle, but it's not even getting close. And then it's like, oh, I really want to be in the circle, but I can't. So, these are neat. Now, what if we switch this with another one? Like, here's a different trig function. Pretty similar, actually. How about cotangent? This one's quite different. Let's try fiddling with this for a minute. Well, sometimes you gotta zoom in so it's not too crazy. Okay, zooming in a bit. This one does look like a really big flower. Oh! Okay, this one's too crazy. Ah! Yeah, this one goes far too crazy. We have to control it ourselves. We cannot trust the robot slider. Does look like a pupil of an eye to a degree on some of these. And a flower. Look at that flower. This is pretty cool. And here's simpler states. Look at this simpler state. Still quite beautiful. Oh no, my friendly numbers are blowing everywhere. I need to pin these down. Okay. Lot of fun, different options here. And I tried putting this up to other powers and it made it a little too crazy. I'm going to try adding a power outside here, but I am going to just do one power at a time. So this is, we only have A as a slider, but we have squared on the output. So these are what we can get when we are squaring a particular thing there. And I think it might have been more interesting when we did have that theta in front. I might have to stick that theta back to try this experiment. Squared makes it go pretty wild, though. Now, cubed might do funny things because cubed is a lot different from squared. It's an odd function as opposed to an even function. And so, like, fourth powers are very similar to squares and even are included as part of the squares. Cubes are a bit different. You know, you could... Ooh, that one's pretty neat. On the simplest sense, we could say that if I have y equals x to a power, then if it's... Pretend I'm only on the whole numbers. If the power is 1, boring. Power is 2, we get a parabola. Powers 4, we get like a steeper parabola. 6, we also get a steeper parabola. But an odd amount on it makes it go crooked. Like, you know, it makes it go the other angle on that side. In fact, a key difference is that this one, they both have a different type of symmetry. This one has an axis-related reflectional symmetry, and this one has a rotational symmetry. You could rotate that to meet that one. Same with all the odd ones. So when we stick anything odd as a power in a function, it's going to be a little different than when we stick anything even up there. So somebody said 1 over theta could be fun, and I agree that could be cool to try putting the theta on the bottom here and deleting that one and sticking, maybe we'll have A over theta so we can have control over a variable. Here is that, but we're on cotangent, which I'm not sure if cotangent was our best. We're going to go back to sine and then secant. So here's sine of that. That's cool. It sort of like unwinds. Or here it's winding back into a circle. And then it sort of unwinds. Now, what if we try that with our other trig functions? This is secant. So that is pretty neat when we put the theta on the bottom there. Oh, it's expanding that weird little circle out there. Now, what if we try throwing... We'll try 1 or 2 more of these first. Tangent, as we know, can be quite wild. Oh, no! I lost one. Okay. No, I lost all my settings. Okay, slow again. Go slow if I tell you to do a slow. And we'll go from 0 to 100. And then do a lot of steps. All right. So here's that. So this is pretty wild as usual. I love these graphs. So beautiful how simple of an equation this is and how crazy of a pattern it can generate. I would like to see other ways of animating this as well. For example, here I can only animate a slider of the A changing. I would like to find a way to animate, I don't know if they do this on this program or not, a way of zooming in on it on a slide or zooming out. I would also like to find a way of adjusting this range on a slider, slowly expanding which amounts of theta I'm considering. And we have a cat visitor. It's Sassafras. Sassafras is the stray one I was talking about earlier. Hey, Sass. Come here. Sassafras. Oh, he's going all the way over there. Sass. Okay. Yeah, it's okay. I'll give you pets, Sass. Oh, wow. He wanted to go up the fence. He went up on the fence. Do you see him up there? Hey, Sassafras. You're a good climber. Maybe he's camera shy. He's a love lord, though. He will, like, in the morning come just begging for pets. And, like, a year ago, he would barely let us touch him or pet him. But now he just comes begging for love. So, a lot of these were quite beautiful. Leave a comment if you have any other requests. I think I need to run inside for another 2-minute break to use the bathroom real quick, and then we will do 1 or 2 more topics. And if anyone leaves early again, check the cool stuff in the description, and I love you. But stick around if you want. Keep an eye out for the squirrels that could potentially come to grab that nut in the background, and I'll be back soon. Actually, you know what? We're going to put a cool spinning graph on the screen because that will look way cooler while I'm gone than having nothing there. So we're going to go to one of our classics. And we're going to watch a weird spinny thing on the screen. Okay, that will be fun, but still keep an eye out for squirrels too. I'll be back soon. All right. Might need to test this little cool thing. We got something cool here to test. So I grabbed two things while I was out. One of them requires the thing I need to find right here. I need to find my jar of bubble fluid because I got another little bubble machine to test. Now, I have 2 brands of bubble fluid. I don't know which of these will be better. But, so, my old bubble machines, I believe I may have left out in the rain, and I'm not sure if they're functioning anymore. I had a bubble machine that was a cheap one I bought online that it rains at very random times here, and I try and put everything into plastic containers and put tarps on stuff and etc. But I don't always catch things in time for the rain. Like the other night, luckily I didn't have anything out because it just rained for like 5 minutes out of the blue. Now, maybe that's related to some large California storms that are coming. They're not going to affect my area that much, but I live in California. I live in more central to western California, like I'm on the Bay Area, which is on the west part, about halfway up California. But a big storm is actually about to hit. Like, let me show you where this storm's about to go. Storm Hillary apparently is going to hit a large stretch right here of California. These are some places with some precipitation totals, and I think there's a chance that some people are having to evacuate because this says Death Valley had this was on CNN, just randomly the first article I pulled open. Says Death Valley was the second wettest day in history on Sunday with 1.68 inches of rain. That's not that much for some places, but Death Valley is pretty dry. Now, Palm Springs is... and actually, whoa, that is a lot for one day. That is a lot of rain anywhere for one day. Now, Palm Springs, extreme flooding and roads closed, 911 lines down. Oh, that sounds dangerous. All the 911 lines are down. Uh-oh. So, good news is that I live up here, so I'm not going to be affected by the storm, most likely. I do have family in LA. I wonder if any of them are going to have to evacuate. Now, a lot of people in the business industry move to LA because it's a good place to make connections if you're a YouTuber or a Hollywooder or whatever. I don't know if I'll be able to get myself to do that ever. Maybe we'll visit there sometimes, but I need somewhere that's less city-like. Even living here in the Bay Area is too city-like for me, and I'm in a not as city-like part of it. So if anywhere, we're going to move out in the woods someday. We're going to be somewhere random in California in the middle of the forest with a river, and we're going to build a combo castle next to the river. And on certain days, maybe you folks will get to visit. Now, lots of cool things in our comments. Thank you all for joining me to chat. And the other thing the 2 things I brought, I didn't mention this one. This was an apple I picked right now from the tree because you see when you have fruit trees and you wonder if a fruit's ripe, well, the one way you can definitely know a fruit is ripe is if it recently fell. Some fruits get damaged when they fall if they're a very fragile fruit, but say an apple is pretty durable. And if an apple fell off the tree, you know that thing's ripe. And in fact, you should look on the ground next to trees because when they fall, they're good for a few more days typically. But the other way to know is if you see one on the branch, you give it a little tug and you see if it comes off lightly. Same technique with a berry. If you go blackberry picking, which I will be doing in a day or 2 for next episode, you give it a tiny little tug. And that tiny little tug is enough to tell you, did it come off, meaning it's ready, or should I check the next berry? Now, this came off with the lightest tug, was the reason I was saying that. You knew this fellow was right because I was just like, dink, and it just instantly came off. Now, these apples, this one's pretty fresh. It doesn't have much bug damage, something a little weird down there, a couple little nicks right there or something. I might not eat that part of the skin. I might eat around that part. but typically a pretty good apple. Many of them even have another bug bite or two that you often need to cut around, but this is just a fresh apple. Now, I brought it as an example of how the first apple tree has borne its apples, and the other apple trees in that yard I share with neighbors will also be bearing apples soon, and we are going to have an abundance of them. We are going to have almost what we could call an arbitrarily large number. That is more of a joke comparison, but it feels like an arbitrarily large number of them. Now, with these, I'm going to have to make some apple recipes, so send me your requests, because you know that we are going to be making some applesauce, you know we're going to make an apple pie or two, but I'm going to have too many apples to know what to do with. Some of the neighbors are even moving, and usually the other neighbors don't eat many of the fruits in the yard, and it's on me and my family to figure out something good to do with them. If they fall on the ground and they're still ripe for a few days, I'm like, oh, I got a few days to use this nutrients, to use this resource I've gotten for free. Having fruit trees is a beautiful thing, and I recommend more people, if you happen to have any space in a back or front yard, plant some more stuff. Maybe an apple tree won't be ready right away, but you or your kids may enjoy an apple tree you plant, or any sort of stone fruit, or whatever grows well in your region, some sort of berries, or if you would like a quicker, something that you can eat within a year, plant some tomatoes or something, or some peppers, or there are plenty of things that could be planted. And I got that planter back there that has now accumulated so many fallen clocks that it stopped making the potato greens. They must have gotten knocked over with clocks and cats and squirrels and stuff. But at this point, the potatoes still seem to have grown. I'll show them more again next time. There's potatoes in there I've shown before. We'll save that for the episode about 5 ways potatoes can kill you. Now, which we won't prove, we'll just explain. Now, somebody's noticing another thing coming ashore near San Francisco. It's separate from the tropical storm. Let me look that up real quick. Is there another mini storm that's coming to San Francisco or something? I don't live in San Francisco. I live in the East Bay, but that's very close to it. So, yeah, I don't know. I'll look out for that. There could be some rain. Looking like in my zone, I'm not seeing any rain, but today does say straight up clouds, which always means like you're on the fence. Precipitation percentages are also a little misleading. It doesn't always mean what you think it means. It can mean like the percent of chance of rain can mean like we'll go into that more when I know more purely how to say this accurately, but the precipitation ratings are a little more confusing than you think. Now, of course, they can't predict any of that perfectly, and they're just doing their best. And I am grateful that they give us some sort of guess of what the weather is going to be. That's a cool societal service for sure, that they make some sort of guess. If you were back in the day, your best guess would be looking at the clouds. That only gives you sometimes an hour of warning, if that. And nowadays, you can look online and say, hey, they guessed that there's going to be rain. But we are going to have to sometime do an episode about precipitation ratings. Also, this is one of those topics I just have to say real quick, that some people for some reason consider this to be a political issue, but it shouldn't be. It should be a human moral issue, is that climate change is real and is a lot of it caused by humans. So we have to work on that as a species. It's a very pressing concern for the species to change the way that we pollute the air, which relies on us assembling governments that don't let corporations get away with as much pollution. It's not the car you're driving that'll help to ride your bike more, but it's more so about passing laws that don't let corporations get away with as much. So climate change is a very pressing issue, and although some people think that's a political issue, it shouldn't. It should just be a human issue to admit scientifically it is greatly caused by humans, and we need to figure out something about the way humans are polluting the planet, because something's not working right there. Same with the amount of plastic humans generate. something's not working there. So those are pretty pressing concerns. You know, a lot of the math we do is more pure math, almost to appreciate the beauty of the universe. But occasionally, if we get into nature, we do have to note that some of the appreciation for nature can also go hand in hand with putting in work to help environmentalism. That is, like I've said, you know, one of the only things that I'll consider more important than the number facts I have to tell you is making sure that all of you not only enjoy but respect nature and understand the importance of keeping different climates, having diverse different types of animals and plants that aren't all ruined by humans. So that will be something maybe we will discuss in more depth in the future, but for now, all you can really do is know that it's an important pressing issue and try and use a little less gas yourself, but don't feel too guilty. More so work on voting if there's ever any laws passed related that you may get the chance to vote on that force corporations to do certain things less. Now, that's all for that, but we love nature around here. We'll take a bite of this apple in a minute. Oh boy, there's going to be figs next. Figs are going to be ripe soon in the yard. And for some reason, the fig tree I have does 2 miniature seasons. We got like 10 figs were already ripe. Then it paused for a few weeks. And then it's going to do the bigger batch. It always does that. It does like one in summer and one in fall. It's weird. But we're going to get a bunch of figs. We're going to get pears. We might get grapes. There's grapes in like the more of the neighbor's side of the yard. But usually we chat with them and are like, hey, can I grab some of those grapes? Or in this case, it might be right when the neighbors are moving and it's like in between owners and then they're my grapes. But I mean, obviously I'm not going to take all of any of those grapes. We will ask and share, but there's a lot of good grapes on that side of the yard. Now, other plants that will appear include, other random fun stuff you will see in the front yard. Now, around the Bay Area, when you want to look for wild trees, you can sometimes find them in nature, and it's typically either blackberries, the one we'll be doing this week, or plums. You can sometimes find plum trees around the area. I still believe that this might be a plum tree that rarely bears fruit. In fact, both of these might be. Because not only do I recall in the distant past a tree similar to these that bore plums from the neighbor's yard that looked similar to these but was in their yard that is gone now. Which, oh boy, do I have a story about that plum tree. Oh my God, the fire department, the cops, there's a story about that plum tree for later. But I think this could be one because I saw a plum in this planter bin. It was either something a squirrel had left there without eating, or it had fallen from this tree. And when I looked, I thought I could see another plum up there. I need to get some binoculars or something, but I thought I could see like that it might be really rare, but this tree might make a few plums, which I really need to look into. How do you make a not often fruiting tree fruit more? I need to know that. I need to know how to rejuvenate the plum trees or whatever. Figs as well have an interesting story where I need to figure out to what degree this applies to the figs in my yard. But many figs are pollinated by wasps in a way that many people find quite creepy. You see, the wasp goes in the flower, pollinates the flower, and dies, and the fig grows around that using the wasp as fertilizer to grow. Now, that doesn't mean that when you bite in a fig and you get something crunchy, that's a wasp. The crunchy part is the seeds. You're not going to taste a wasp. It's so far gone, it's like if I buried a wasp and used it to grow a strawberry plant and then ate the strawberry. The wasp was like fertilizer for it. But it was sort of inside it. It's like fertilizer that grew and became it. So some breeds of fig that I think might include the one in my front yard require one wasp per fig to pollinate it, die inside it, and become part of the fig. Sorry if I've scared any of you away from eating figs. Remember that the wasp is no longer part of it by the time you get the fig. It's completely decomposed and recomposed. Now, we're going to look into that more when we do a Fig episode sometime, but we already had some snack breaks recently. Our next episode, although you may see some blackberries in earlier parts of it, it's not a snack break. The blackberries are a demonstration about arbitrary largeness, so we'll see what I mean by that in the next one. Now, I think that I may wrap up our stream in the near future. We do have a lot of other fun variations on all those wild graphs we could cover, and a variety of other things, including one more test I would like to conduct, which is, this was a new bubble machine I got to replace the old one. It's much cheaper and smaller. I got it for free, and it looks like SpongeBob's home, you know, like the cartoon character SpongeBob lives in a pineapple that I feel like might look kind of like this. I don't know. It's a pineapple. That's funny timing, because you know what? Guess who just took a giant bite out of the pineapple, including the skin? Well, if you say, I don't know who, you need to watch my second last combo class episode. Well, this pineapple apparently is a bubble machine. It doesn't even seem to have a plug. This one's battery powered, which is different. However, I think I got batteries in it, and let's see if it works. Yeah, we're getting some bubbles. So as usual, I need to be very careful about not letting them go on the computer screen, but let's just blow them back there for a moment and see some bubbles. Okay, they are starting to go on the computer screen. We're only going to do this for like 1 second. But this is going to add some bubbles into the next episode. I'll make sure to add some bubbles to make up for the fact that the last bubble machine unfortunately broke due to being left out in an unexpected rain. Might be fixable, but this one works for now. So, bubbles, that's always fun. Another thing that when I was a child I loved, and then when I was a teenager I thought, bubbles aren't cool anymore. And then at a certain point of adulthood, I realized, wait a minute, bubbles were cool all along and still are. So, thank you all for joining me. I am going to wrap up the stream here. We'll end with a nice bite out of this fresh apple. Make sure you've tuned into the latest combo class episode in the description, as well as the next one that will be coming out in a few days. And special thanks to all my Patreons and stuff who are linked in the description as well. All those names, extra special thanks because they help the show continue and grow. And I do have fun plans to continue growing over the next arc of grade -2, now that we are in approximately the middle third of grade -2. So, lots of fun stuff to see in the future. I love you all so much. Thank you for joining me, and I'll see you very probably soon.